The universe is full of patterns. Some are simple, easy to see, like the sun rising each day, or the steady march of time. We understand things that add up. 1 plus 1 equals 2, then 3, then 4. This is linear thinking. It's comfortable. It's how we often experience the world around us. But there's another kind of growth, a more dramatic, more powerful kind. It's not about adding, it's about multiplying. Imagine a magical seed. Plant it, and it sprouts 2 stalks. Each of those stalks then sprouts 2 more. This isn't just adding, it's a chain reaction. This is exponential growth. It's a force that can build empires. Let's conduct a thought experiment. No fancy labs needed, just you, your imagination, and a single sheet of paper. Any paper will do. Hold it in your hands. It's thin, isn't it? Perhaps 1/10 of a millimeter thick. What power could this flimsy sheet hold? Now fold it in half. Smooth down the crease. The paper is now twice as thick. 2 layers, still very thin. This is how exponential growth often begins. Unassuming, almost invisible. Our linear brains might dismiss it. Just a tiny bit thicker, we'd say. This simple act of folding holds a profound lesson. Let's continue our paper folding journey. We are at 2 folds with 4 layers. What happens with the 3rd fold? We double the 4 layers. Now we have 8 layers. At the 4th fold, we get 16 layers. The 5th fold gives us 32 layers. Notice the numbers 1, 2, 4, 8, 16, 32. Each step is twice the previous one. The thickness is growing, and the rate of growth is also growing. After 7 folds, we have 2 to the power of 7. That's 128 layers of paper. If our paper started at 0.1 millimeters thick, it's now 12.8 millimeters thick. Suddenly, it's a noticeable thickness. We've gone from something almost imperceptible to something quite tangible in just 7 simple folds. Imagine that. Now you might be thinking, wait a minute, can I really fold a piece of paper 20 times? And you'd be right to ask. Our thought experiment is powerful, but the physical world has its own rules, its own stubborn limitations. Try folding a regular piece of paper. After 5 or 6 folds, it gets incredibly difficult. The paper becomes thick, it resists, it crinkles. The world record for folding a single sheet of paper is a subject of some debate and depends on the paper's size and thickness. For a standard A4 sheet, most people can't get past 7 or 8 folds. At each fold, the paper not only doubles in thickness but also halves in its other dimensions. It quickly becomes a tiny, dense, uncooperative lump. The material itself fights back. This doesn't diminish the power of exponential growth as a concept. It simply reminds us that mathematical ideas interact with the physical universe. The equations can soar to infinity, but materials have breaking points. Even with physical limits on folding a single sheet, the idea of continued doubling remains potent. Let's imagine we could keep folding. What would happen next? After 10 folds, our paper stack was about 10 centimeters thick, like a small book. After just a few more folds, it would tower over everyday objects. It's time to recalibrate our sense of scale. At 14 folds, we'd have 2 to the power of 14 layers. That's 16,384 layers. The thickness would be about 1.64 meters. That's taller than many people. Imagine a stack of paper reaching above your head, all from that one initial sheet, folded just 14 times. Think about that. Each fold still just doubles what's there. But what's there is already substantial. The increases become dramatic. Let's push it to 17 folds. Now we have 2 to the power of 17 layers. That's 131,072 layers. The thickness about 13.1 meters. Our imaginary paper stack is growing at an incredible rate. Each fold doubles its thickness, and the results are astonishing. At 17 folds, it was as tall as a 4-story building. Imagine that, a simple piece of paper reaching such heights. What about a few more? Let's try 23 folds. The growth is exponential, and the numbers quickly become mind-boggling. That's 2 to the power of 23 layers. Each fold multiplies the previous thickness by 2. The number of layers is now over 8 million. Yes, you heard that right, 8 million layers from just 23 folds. And the thickness? It would be approximately 838 meters. That's an incredible height for a piece of paper. That's nearly a kilometer high. Think about that. A single sheet of paper folded 23 times, reaching almost a kilometer into the sky. How does 838 meters compare to things on Earth? Let's put it into perspective. The Burj Khalifa in Dubai, the world's tallest building, stands at about 828 meters. Our paper stack would surpass it. So with just 23 folds, our humble piece of paper, in theory, would be taller than the tallest structure humanity has ever built. It's a staggering realization. Imagine that single sheet, now a colossal pillar piercing the sky. It's a staggering thought. The power of exponential growth is truly mind-blowing, all from simple repeated doubling. Let's not stop there. What about 25 folds? The numbers continue to grow exponentially. That's 2 to the power of 25 layers. Each fold adds another layer of complexity and height, about 33.5 million layers. The numbers are almost too large to comprehend. The thickness would be roughly 3,355 meters, or 3.3 kilometers. That's taller than many mountains. Many mountains aren't that tall. Our paper stack would dwarf them. This paper stack would rival significant peaks on our planet. The sheer scale of it is almost unimaginable. We've reached the edge of space with 30 folds. Imagine that, a simple piece of paper folded just 30 times, reaching the very boundary of our atmosphere. Our paper stack is 107 kilometers high. But the moon, our closest celestial neighbor, is much farther away. The moon is much farther away. It's not just a hop, skip, and a jump. The average distance from Earth to the moon is about 384,400 kilometers. That's nearly 10 times the circumference of the Earth. Can our folded paper make it? Can this seemingly impossible task be achieved? Can this exponential journey bridge that vast cosmic gulf? The challenge is immense, but let's explore further. Let's keep folding in our minds, of course. Each fold doubles the thickness, taking us exponentially closer. Where will this incredible progression take us? The journey is fascinating and full of surprises. How many more folds would it take? Let's do the math. At 30 folds, we had 107 kilometers. That's already an impressive height. We need to cover 384,400 kilometers. Let's try 40 folds. Can we get closer? That's 2 to the power of 40 layers. The numbers are getting astronomical. The thickness would be approximately 109,951 kilometers. That's a significant leap. That's more than a quarter of the way to the moon. Impressive, but we're not there yet. But not quite there yet. The moon still seems distant. The moon still beckons from afar. It's a tantalizing goal. Let's aim for 42 folds. Can we reach it with just 2 more folds? The number of layers would be 2 to the power of 42. The exponential growth is mind-boggling. That's roughly 4.4 trillion layers. And the thickness? Prepare yourself for a surprise. It would be about 439,804 kilometers. That's more than the distance to the moon. This is more than the average distance to the moon. With just 42 folds, we've surpassed our goal. The power of exponential growth is truly astonishing. Why does this feel so surprising, so counterintuitive? It's because our brains are not naturally wired to understand exponential growth. Reaching the moon by folding paper? It seems impossible, right? It sounds like science fiction, something out of a futuristic novel. Yet, the math is straightforward. It's simple multiplication. 1 times 2 times 2 times 2 times 2, again and again. This is exponential growth. The culprit is our own brain. It's not designed to intuitively grasp this concept. Our everyday experiences shape our intuition. We are used to linear growth, and most of our everyday experiences involve linear growth, not exponential. Linear growth is predictable and easy to understand. We are wired for addition, not rapid multiplication. Our brains handle simple arithmetic well. Our brains evolved to deal with immediate surroundings. We focused on survival, predators, food, shelter. These were our primary concerns. These things often changed in predictable, linear ways. Nature followed a certain rhythm. If a threat got closer, it moved at a certain speed. We could track it. If we gathered berries, each handful added a small, consistent amount to our supply. This built-in linear bias makes it hard to grasp the explosive nature of doubling when it really gets going. Exponential growth is a master of disguise. It starts incredibly slowly, almost imperceptibly. The first few folds of paper barely change its thickness. It seems insignificant. 1 layer, 2, 4, 8. These are small numbers. They don't seem to add up to much. Our brains register this slow start, and we extrapolate. We think, this isn't going anywhere fast. If it continues like this, it will take forever to get anywhere significant. But that's where we are wrong. Exponential growth doesn't stay slow. It accelerates rapidly, and before we know it, the numbers skyrocket, leaving us astonished at how quickly things have changed. This isn't just a curious trick with paper. Exponential growth is everywhere. It's one of the universe's favorite patterns. Look at technology. Moore's law for decades described how the number of transistors on a microchip doubled roughly every 2 years. This exponential increase in computing power has revolutionized our world. From room-sized computers to the smartphones in our pockets, that's doubling at work. Consider biology. A single bacterium divides into 2, those 2 become 4, then 8. Under ideal conditions, populations can explode exponentially. The growth of a human embryo from a single fertilized cell to trillions of cells follows this pattern of rapid multiplication. Life itself, in its quest to spread and flourish, often harnesses the power of exponential increase. It's a fundamental driver of biological change and diversity. Think about finance. Compound interest is exponential growth in your bank account. Money earning interest, and then that interest earning more interest. Albert Einstein reportedly called compound interest the 8th wonder of the world.